Hi guys, this is Vineet and I welcome you to this video. Today's video topic is how we can tune indexes using the missing index suggestions in SQL Server. So before we proceed ahead, I would request you all guys to please go ahead and subscribe to my channel. There's a subscribe button below this video. Click on that subscribe button. It will give you a bell icon. Click on that bell icon, select all notifications to get notifications regarding all my future videos. The reason I'm asking you to subscribe is because I don't want you to miss on any of the videos that I will be releasing on indexes in the coming 15 to 30 days. So I will post around 15 to 20 videos that are pending regarding the indexing topic. So I don't want you to miss any one of them. So that's why I'm asking you to subscribe so that you can get timely notifications on these videos. So let me give you 5 seconds so that you can subscribe right away. Please go ahead and subscribe. So guys, I hope you must have subscribed by now so we can move ahead. There are some points to remember while watching this video. Please watch this video till the end to gain better clarity of the concept, and if it's possible for you, please watch this video twice or as many times as you like until the concept gets clear to you. Perform any exercises in your test and lab environment solely. Do not touch any production environment or production databases. We would like to know your thoughts regarding our videos, so please do share in your comments and stories. We eagerly wait for your comments and stories and would love to read them. We have created some playlists for you to watch. Some of the common SQL Server playlists are database design, tables, business continuity, indexing, performance tuning, integration services, and transact SQL. The reason we have created playlists for you is because we feel that playlists are best way to learn about any particular domain. So for example, if you want to learn about SQL Server indexes, what we would recommend is go to the SQL Server indexing playlist and watch out all the videos from starting till the end. And if we talk about this video also pertains to the SQL Server indexing category. We have posted more than 240 videos on our channel, and the number of videos are growing at a constant pace. So please go ahead and watch out all these videos, but we would recommend go via playlists. And we have a channel page as well. Link is given at the bottom of this page. And guys, link for all these playlists and the channel link page is also given in the video description area for this video. So please check them out. So let me go back to notes quickly. So let's come back to today's topics, which is how you can tune indexes using the missing index suggestions in SQL Server. Let me take you through notes. This will be a mix of theoretical and practical session. So first there will be theory. So let me discuss on that, and then I will show you or practically demonstrate you how you can work with the tuning non-cluster indexes with missing index suggestion. I will show you practical on that as well. So today's topic is tune non-cluster indexes with missing index suggestions. Now, if we talk about the missing index feature, this feature is a lightweight tool for finding missing indexes that might significantly improve the query performance. So this is basically one of the feature which is called the missing index feature, and this feature is a lightweight tool and it helps us in finding the missing indexes on a table that can significantly improve the query performance, the query that we are running on this on the table. And if we want to improve the performance of that query, we can consider creating these missing indexes, and we will shortly show you how to use these missing index suggestions to effectively tune indexes and improve the query performance. Now let me first discuss about some of the limitations of missing index feature. There are certain limitations to it as well. Now, when a query optimizer generates a query plan, it analyzes what the best indexes are for the particular filter condition. So it's the role of query optimizer, which basically generates the query plan. It basically analyzes all the best indexes available for a particular filter conditions that are being used in the query. And if the best indexes don't exist, so if a query optimizer finds that the best indexes do not exist, the query optimizer still generates the query plan using the least costly access methods available. So even though the best indexes are not available on the table as well, in those cases as well, the query optimizer still generates a query plan by using the least cost mechanism or least cost access methods available. and but it also stores information about these indexes which are missing and which can improve the performance of the query. So query optimizer also stores the information about these indexes, and the missing indexes feature enables you to access that information. So whatever information is stored by the query optimizer regarding any of the missing indexes that can improve the query performance, we can use the missing indexes features to find out or access that information about best possible indexes so that we can decide on whether they should be implemented or not. Now, query optimization is a time sensitive process, so there are limitations to the missing index feature. So as we discussed earlier, there are certain limitations that are applicable on the missing index features. And if we talk about the query optimization process, it's a time sensitive process. Now, missing index suggestions are based on estimates made during the optimization of a single query. So any of the missing index suggestions are basically based on the estimates that are made during the optimization of a single query. And prior to the query execution, so these are the index suggestions that are calculated on the base of estimates made during the optimization of a single query prior to its execution. So even before the query is executed, the missing index suggestion are basically based on the estimates of the optimization of a single query. And missing index suggestions aren't tested or updated after query executions. So if we talk about missing index suggestions, these are not tested or updated even after query execution. Now the missing index features suggest only non-clustered disk-based row store indexes. So if we talk about the missing index feature, this feature basically only suggests the non-clustered row-based indexes. Unique and filter indexes are not suggested. So this feature does not suggest any unique indexes or the filter indexes that are equivalently useful in certain situations. It only suggests about the non-clustered disk-based row indexes. Now key columns are suggested as well. So whatever columns that are suitable for the key are also suggested, but the suggestion doesn't specify an order for those columns. Although the missing index features do suggest about what columns are suitable for the key, but it does not suggest the order of these columns to be used in the index. Included columns are in fact suggested by the missing index suggestions, but SQL Server performs no cost benefit analysis regarding the size of resultant index when the large number of included columns are suggested. So if we talk about the missing index features, it also suggests the included column as well, but SQL Server do not perform any cost benefit analysis on the suggested indexes. Cost benefit analysis in terms of the size of the resulting index when a large number of included columns are suggested. Now missing index request may offer similar variations of indexes on the same table and columns across queries. It is important to review index suggestions and combine where possible. So if we talk about the missing index feature or missing index request, it may basically offer you similar variations of indexes on the same table and columns across the queries. And it is important for us to review these index suggestions and combine the two indexes wherever possible. And these suggestions, if we talk about, aren't made for trivial query plans. Alright, and cost information is less accurate for queries involving only inequality predicates. The cost information is less accurate and that is one of the limitations for queries that are involving the inequality predicates. Now suggestions are gathered for maximum of 600 missing index groups. If we talk about suggestions, these are gathered for maximum of 600 missing index groups, and after this threshold is reached, no more missing index group data is gathered. So once the missing index feature gathered the data for 600 missing indexes, and after this threshold of 600 missing indexes is reached, no more missing index group data is gathered by the missing index feature. And due to the above limitations, missing index suggestions are best treated as one of the several sources of information. So basically, to summarize, we would say that we should only use missing index suggestions as one of the several sources of information. When we perform the index analysis and design and tuning and testing of that particular index, we can use that missing index information. Now, missing index suggestions are not prescriptions to create index exactly as suggested. So yeah, this is important point, guys. Missing index suggestions are not prescriptions to be followed as is to create an index exactly as suggested. You can review that information, see and feel whether that index is appropriate or not. Maybe you can combine certain indexes as well. So use your own mind before using the missing index suggestions to reap any query performance benefit. Now, if we talk about Azure SQL database, it offers automatic index tuning. And automatic index tuning uses machine learning. So if we talk about the automatic tuning index tuning process, it uses the machine learning to learn horizontally from all databases in Azure SQL database through AI and dynamically improve its tuning actions. So automatic index tuning feature in Azure SQL database uses the machine learning algorithms to basically learn horizontally from all the databases in Azure SQL database through artificial intelligence and dynamically improve its tuning actions. Automatic index tuning includes a verification process to ensure there is a positive improvement to the workload performance from indexes created. So this is also one of the important features of automatic index tuning. It basically includes a verification process where after implementation of the index, it checks whether that created index has improved the performance or the workload performance from the indexes is created or not. So it learns from that. Now let's talk about viewing the missing index recommendations. How do we view that? The missing index feature consists of two components basically. The missing index element in the XML of the execution plans. So if we talk about the execution plans, this XML execution plans contains the missing index element which we can view for any missing indexes. And this basically allows you to correlate indexes that the query optimizer considers missing with the queries for which they are missing. And the second thing it consists of, the missing index recommendation consists of is a set of dynamic management views that can be queried to return information about the missing indexes. So similarly, dynamic management views can be also queried to return information about any of the missing indexes. And this basically allows you to view the missing index recommendations for a database. Now, query execution plans can be generated or obtained through multiple ways. Here we are talking about generating the query execution plans. So these can be generated or obtained via the multiple ways. Now, whenever we write or tune a query, we can use the SQL Server Management Studio to display an estimated execution plan. So guys, you can watch out my videos on how to generate the estimated execution plan to get an idea on how do we generate an execution plan. Even though in this video, we will show you practically how to generate an estimated execution plan. But if you want to jump ahead and right now check how the estimated execution plans are generated, you can watch out that video as well. So for writing or tuning a query, we can use the SQL Server Management Studio to display an estimated execution plan without actually running the query or without actually executing the query and display an actual execution plan. Secondly, we can use query store if it is enabled on the database, and when it is enabled, we can collect execution plans from the query store as well. We can identify cached execution plans by querying the dynamic management views. So dynamic management views can also be queried to view any cached execution plans in the memory. And one example of this dynamic management view is sys.dm execute text query plan. It's one of the dynamic management views that we can query to identify the cached execution plans. Now let me take you through a demo, and in this demo we will discuss about how to view the missing index suggestions in an execution plan. So basically we will need SQL Server to generate that missing index suggestions. How we can view the missing index suggestion, let me show you where the SQL Server Management Studio. Have just invoked the SQL Server Management Studio. It should open up in a while. So SQL Server is open, guys. Let me connect to it quickly. The example database that we will be using in our practical is the AdventureWorks 2022 database. In my case, it's my AdventureWorks because I had renamed it. But yeah, for you, it must be AdventureWorks 2022 database. If you have not installed that database, I would suggest watching the online content to see how to install the AdventureWorks 2022 database. Let me trigger a new query and write a new query for you. So guys, you may write that query along with me. So let's do select star from. The table we are using in this scenario is the person.address table, and we are taking the abbreviation for this table as A, and we are joining this table with person.business entity address, and we are taking this table name as BA, and we are joining these tables on the address ID column. So we are referring the A.address ID column, and we are joining it with the business entity address ID column. So these tables are joined. Let me join these further with one more table, which is person.person. I'm joining it with. I'm taking this table as P, and we are joining on PA dot or business entity address dot business entity ID. We are joining on the business entity ID column, and we are joining the business entity ID column of business entity address table with the business entity ID column of person.person table. So now we have joined three tables, and we are also taking the filtering condition. And filtering condition we are taking where person.first name like anyone starting with letter K, we are taking as person name. And second filtering criteria I'm taking as where the state province ID is equal to 9. Alright, so this will be our query that we will be using in this example. And let me refine the columns. I do not need all the columns from these three tables. So I need city, I need state province ID, I need postal code. So this is all information I required. I do not want all the columns, but instead I just want these three columns. So you may write down that query in order to follow the practical. Now let's deep dive into practical. So what we have done so far is we have connected to SQL Server Management Studio, and we have connected to the AdventureWorks sample database, and we have written in the query. So query is there in the session. The session ID for this session is 58. Now let's select the display estimated execution plan toolbar button. So let's select this one button, which is include the, we don't need this one, but we need an estimated execution plan. So this is the button for estimated execution plan. Click on it to turn it on. So whenever we click on this button, it generates an estimated execution plan. So whenever we click on that button, the execution plan will display in a pane in the current session. And if we take a look at the green line in this execution plan, so we have a green line here, right, indicating the missing indexes. So a green missing index statement will appear near the top of the graphical plan. So this is our graphical plan area. Over the top of that we see green color line indicating the missing index statement. And if we talk about a single execution plan, it can contain multiple missing index requests, but only one missing index request can be displayed in the graphical execution plan. One option to view the full list of missing indexes for an execution plan is to view the execution plan XML. So if we take a look here in the graphical view, we only see one missing index suggestion, even though there could be multiple missing indexes that are present, which we can view via the execution plan XML, and we will show you how to do that. So if you want to see whatever missing indexes are, so if we take a look at the missing index statement here, it is asking us to create a non-cluster index on person.address state province ID column, and it is also giving us the included column suggestions to include the city and postal code in the included columns, and create a index on person.address column on the state province ID column. So why it is suggesting the included columns as city and postal code? Because here we are selecting it in the select statement, so that's why it's asking us to include those columns as well. Now if we want to see all the missing indexes, so here if we see it is only telling us to create one missing index, right? We can see in our tooltip, right? Now if we want to see all the missing indexes, we can right click on the execution plan, and select show execution plan XML. So when we click on this, it will show us the execution plan XML for this query. And the execution plan XML will open as a new tab inside the SQL Server Management Studio. So if we take a look at this XML, so guys, we are talking about this. So this is the missing index suggestions. And if we talk about the graphical area here, it will only show a single missing index suggestion in the missing index details, right? Even if multiple suggestions are present in the execution plan XML. So our execution plan may contain multiple suggestions for the missing indexes, even though the GUI will show only one missing index suggestion. And the missing index suggestion displayed might not be the one with the highest estimated improvement. So the missing index improvement suggested here may not be the one with the highest estimated improvement for the query. So we should always check the execution plan XML. Now, in the execution plan, you can display the find dialog box by pressing Ctrl F. Search box, you can type the missing index keyword. So here we see that we have two missing indexes. So there are two tags for missing index. One is opening, one is closing, and again one is opening, one is closing. So the estimated XML query plan for this query is showing us that there are two missing indexes that are required on this table. Now in this example there are two missing index elements, right? We can check that these are the elements. First element missing index and the second element missing index. Now if we talk about the first missing index element here, let's talk about this one. It suggests that query might use an index on the person.address table. So this missing index suggestion is suggesting that the query might use an index on person.address table that supports an equality search on the state province ID column. Alright, and which also includes two more columns. So here it is offering suggestions about the included columns as well. So what are these included columns? These included columns are city and postal code. And at the time of optimization, the query optimizer believed that this index might reduce the estimated cost of query by 34%. So it is showing us the impact here. At the time of optimization, the query optimizer believed that the creation of this index may reduce or might reduce the estimated cost of the query by 34% if we create this index by including these two columns and creating an index on the person.address table on the state province ID column. And if we take a look at the second missing index suggestion, so which is here, right? The second missing index suggests the query might use an index on the person.person table, right? That supports an inequality search on the first name column. And at the time of optimization, the query optimizer believed that creation of this index might reduce the estimated cost of query by 12%. And if we talk about non-clustered indexes, each disk-based non-clustered index in your database takes up space. Alright, so maybe I need to write this down. We have already written. So if we talk about each disk-based non-clustered index in your database takes up space, right? And it adds overheads for any inserts on the table, updates on the table, and deletes on the table. So depending on the how many indexes you have in the database, it basically adds to the overhead on inserts, updates, and deletes. And these indexes also require the maintenance. And for these reasons, it is a best practice to review all the missing indexes request for the table and the existing indexes on the table as well before adding an index based on the query execution plan. So this is one of the important point, you may note it down. Now let's talk about how you can view the missing index suggestions via the DMVs. So guys, we will cover this topic in our next video. So let's assume this as a part 1 of this video, and the video topic today is tune non-cluster indexes with missing index suggestions. And today we have covered how you can view the estimated execution plan to find out about the missing indexes, and we have shown you how to read the XML execution plan for any of the missing index suggested. So in this case we have seen two missing indexes were suggested in our practical. And guys, we are done with this video, and in our next video we will cover how you can view the missing index suggestions in execution plans using the dynamic management views. And if possible for us, we will also create a video on how to persist the missing indexes with the query store. For that, query store should be enabled on your database. Alright guys, let's end this video here. I hope you like the content of this video. If you really like the content of this video, please click on the like button below this video. And guys, if you are new to this channel or if you haven't yet subscribed to the channel, I would highly recommend please go ahead and do so right away. There is a subscribe button below this video. Click on that subscribe button. It will give you a bell icon. Click on that bell icon. Select all notifications to get notifications regarding all my future videos. The reason I'm asking you to subscribe is because I don't want you to miss on any of the videos that I'm creating on indexes in the upcoming 15 to 30 days. So please go ahead and subscribe right away. I'm giving you 5 seconds. Please go ahead and do so. So guys, I hope you must have subscribed by now. And guys, please do post in your comments and suggestions or any stories as well. We eagerly wait for your comments and stories, and we do love to read them. And also guys, if you have a good network of friends who are also working in SQL Server domain, please share my videos with them and ask them to subscribe to my channel in case they like my videos. Thank you so much for your time on this video today, and you have a wonderful day ahead.